Imagine generating electricity without fuel, sunlight, or moving parts, simply by letting the Earth spin. It sounds like science fiction, but physicists in the United States have built a small device that appears to pull electrical energy directly from Earth's rotation. The tabletop experiment produced only tens of microvolts, but the idea behind it could reshape how we think about energy. The research was carried out in New Jersey by a team from Princeton University, working with colleagues from NASA's Jet Propulsion Laboratory. The project was led by Christopher F. Chyba, whose work links electromagnetic theory with planetary environments. Earth is wrapped in a vast geomagnetic field, a magnetic bubble created by moving molten metal deep in its outer core. As the planet rotates, this field stays mostly fixed in space. That means any object attached to Earth is constantly moving through it. For decades, physicists believed this motion was useless for power generation. The standard view said that while electrons might briefly be pushed by the magnetic field, they would instantly rearrange and cancel the effect in less than a billionth of a second. Chyba and his team identified a loophole. They showed that a conductor with a specific shape and magnetic behavior could prevent that perfect cancellation from happening everywhere inside it. Their design used a material that strongly guides magnetic fields but barely conducts electricity. In the lab, this idea became a hollow cylinder about 1 foot long, made from manganese zinc ferrite, a ceramic used in electronics. The cylinder was aligned roughly north to south and tilted about 57 degrees, placing it perpendicular to both Earth's rotation and the local magnetic field. Electrodes at each end measured what happened next. As Earth turned, the device produced a steady voltage between the two ends, tiny but measurable. When the setup was rotated 180 degrees, the voltage reversed direction. At 90 and 270 degrees, the signal nearly disappeared. Control tests were crucial. A solid ferrite cylinder produced no voltage. Another shell designed so magnetic diffusion would not matter also stayed quiet. Only the hollow structure generated a signal. At the heart of the effect is the Lorentz force, which describes how electric charges respond to magnetic fields. Normally, electrons move just enough to cancel that force. In this device, the shape and material prevent that cancellation from fully completing. As a result, an incredibly tiny amount of Earth's rotational energy is converted into electrical energy. The planet slows by an immeasurably small amount, while the device gains an equally tiny voltage, preserving energy and angular momentum. Measuring such weak signals was difficult. The main experiments were run in a dark underground room to reduce electrical noise. The team later repeated the test miles away in a residential building and observed the same pattern, though with more interference. They also corrected for the Seebeck effect, where temperature differences create voltage by continuously monitoring temperatures at both ends of the cylinder. The resulting current was only tens of nanoamps, far too small for practical use. The researchers stress this is an early result. Some physicists argue the effect should not work at all, and the debate continues. The most important next step is independent verification. If confirmed and scaled, future devices might power tiny sensors indefinitely, no batteries required. For now, Earth keeps spinning, and scientists are still learning how much energy that motion might hide.